Okay, so given y equals f of x equals square root of x equals 36/25, we found the point on the graph that has that x coordinate. We found the y coordinate just by plugging this in to the function, 6/5. The coordinates of the point are 36/25, 6/5. And the tangent line is the line through that point, okay, that just touches the graph in one point. That tangent line has a slope that's equal to the derivative of the function. Now the derivative of this function was f prime of x, which is 1 over 2 square root of x. And we've seen the connections between the difference quotient and the limiting value of the difference quotient, so we hopefully understand why this gives us the tangent line for this particular function. We've worked through the details of deriving this. So whether they have all those or not, this is the derivative function. And if we plug the coordinate, the x coordinate here, into this, we get the slope of the tangent line at this point. So we just worked through that. We got then the coordinates of the tangent line, and we figured out that the slope of the tangent line was 5/12. Then we just found the equation of a line with slope 5/12 through the point 36/25, 6/5. And I did that this way, in a way that might or might not be familiar to you, but you learned a long time ago how to find the equation of a straight line with a given slope. Okay? Now you might have memorized some other formula like y equals m times x minus x1 plus y1, which is just what you get if you add y1 to both sides here. Okay? The way I expressed it this way is a little closer to the meaning of a slope rather than a meaningless formula. So I kind of prefer that, but it's okay if you use something different. So I'll put that in this form. Y equals then 5/12 times x minus 36 over 25 plus 6/5. And it's obvious I get that by adding the 6/5 to both sides. Well, I want to simplify that a little bit if I want to use this for anything. And I get y equals 5/12 x. And then let's see, 5/12 of 36/5 is going to be 3/5. So we got minus 3/5 plus 6/5, and that gives us plus 3/5. Now we know that this is a y equals mx plus b form. B would be 3/5. That would be the y coordinate of, or the y-intercept of the tangent line, if you want to put it that way. And let's make sure that this line goes through the point 36/5, 6/5. Okay. Now, if x equals 36/25, 6/5, if x equals 36 over 25, does y then equal 6/5? If it doesn't, we screwed something up. And it's entirely possible that I did. I'm not making a whole lot of effort to be perfect or to appear perfect, okay? So, if x is 36 over 5, then, well, 12 goes into 36 3 times, 5 goes into 25 5 times, and you might have to write that out if you can't visualize well. No reason. That's not a big problem. But that does give you 3/5. 3/5 and 3/5 is 6/5, so this equation certainly goes through this point, okay? Or the line corresponding to this equation certainly goes through this point, and it has the required slope. So we think we've got the tangent line. Okay, now, one interesting question that we ask about the tangent line is, let's take some value of x that's close to 36 over 25, but not exactly the same. Okay? Now, we want something we can take the square root of. So we could use a fraction, you know, we could use 64 over 49 or something. That would be close to 36 over 25. But 36 over 25 is like about 1.36 or something like that, I think. Let's see, 11 over 20, 1.44. Okay? let's ask two things, okay? What would be the y value of this line when x equals, let's say, I'm debating, do I want to use something like, okay, I'm going to say okay, I'm going to use a decimal. I'm going to use x equals 1.21. Okay? I'm probably going to be sorry because I'm going to have to take 5/12 of that and add it to 3/5, which means I'm going to take things and convert them to decimals and stuff like that, so I'm probably going to mess it up a little bit. But I'm going to do that, okay? I'll probably do that off camera because you don't want to watch me. 1.21 over 12 is pretty close to 0.1. So you got like 0.5 here, and this is 0.6, so you're going to get something close to 1.1. So y would be pretty close to 1.1. But it isn't exactly 1.1 because 1.21 over 12 is not exactly 0.1, is it? Okay, well, we can do that sort of thing, that sort of mental calculation. But now, I want to also ask, what is the value of f of 1.21? Well, f of 1.21 is the square root of 1.21. I chose 1.21 because I know what its square root is, and if you know your multiplication tables, at least the squares of numbers up through like 20, which you ought to know, you can quickly conclude that the square root of this number is 1.1. Okay, well, the answer to this question is f of 1.21 equals 1.1. Now, when I calculated this value, I got something, my first calculation gave me 1.1, didn't it? So it looks like I might have done that calculation right. I wasn't faking it, I hadn't figured that out earlier, but it turned out that was fairly easy. But remember that this calculation doesn't give us exactly 1.1. So question is, how close is this calculation to the value of f of x? In other words, how close is this y value to the y value of this function when x equals 1.1? And why should it be different, and why should it even be close? Okay, we want to look at the geometry of this tangent line just a little more, so we'll do that in a minute. But again, understand that all I've done here is simplified the equation of the tangent line, and then I posed a question. What is the value of y if x equals 1.21, and what's the value of f at 1.21?